Hello and welcome to my video showing you how to work out enthalpy changes. This is going to be going through just one method, which is using the formula Q equals mc delta T. There is a previous video which I have made which goes through the 4 formulas you would need to know for A-level chemistry and how to identify by looking at a question which formula you use, and I will tag that in the comments below. So the formula is Q equals mc delta T. It's been taken off the edge of the screen for some reason. So to work this out, you need to have the mass. Now in this question there are 2 masses. It's the mass of the water which is being heated. You need to know the specific heat capacity, which is C. This is either given to you or it will be in your data booklet. And then you need to work out the temperature change. In this case, the temperature has gone up, so you do 65.5 minus 20.5, and that comes up to 45 degrees. So I like to do all my questions, calculation questions, in steps, and we're going to do this in steps. So step 1 for all of my calculations is actually to work out Q. So the formula is Q equals mc delta T. I'm not happy with that, I'll just correct it. Delta T. Delta T means the temperature change. Okay, the mass is 200 times 4.18 times 45, and then that gives me 3762 joules, 620 joules. You divide it by 1,000 to give the answer in kilojoules. So that is step 1. Now we're going to go to step 2, and step 2 is to work out the moles of the hexane, because that's what we are using to boil the water. So I've covered this already in a previous video. Moles equals mass divided by the relative formula mass, or the MR, or the molecular weight. It helps to draw hexane out with all the hydrogens. So the formula is C6H14. And if I use my periodic table to work out the molecular weight, it's 86. So it's 1.29, which is given to you, divided by 86, which is 0.015. So that is step 2. And then step 3 is to take your answer from step 1 and divide it by your answer for step 2. So the answer for step 1, and I'm going to underline it, is that number. Step 2 is that number, so we just divide. This will give me the answer in kilojoules per mole. So 37.62 divided by 0.015 gives me 2508 kilojoules per mole. I think I'll have to add that in later, actually I do. And step 4 is to round it to the required number of significant figures. It's usually 3 significant figures, and also to decide if it's positive or negative. Because the temperature went up, then the enthalpy change will be negative, so we give it a minus sign automatically. So the answer is 2510 when I round it off to 3 significant figures, and it's minus 2510 kilojoules per mole. So I'm going to change the screen now, and I'm going to bring up another question. This is taken from Edexcel AS Paper 2, June 2017. Again, I will reference it in the comments. This one is a little bit different. If you look at the previous paper, there wasn't any diagram. Here they've drawn a diagram for you to illustrate what we're doing in the experiment. And then they give you the results in the form of, it's sort of like a table. So the first thing we have to do, we're looking at how much hydrocarbon was used, because we use the hydrocarbon to burn, and the flame of that heats up the water. So you take away those 2 numbers, the before and after, so we get 0.25 grams of hydrocarbon was used. I'm going to ignore the 250 centimeters cubed of water for now, and now I'm going to work out the temperature change. And the temperature went up by 8.2 degrees. I just take away those numbers. Now usually they give you the mass of the water in grams. Here they've given it to you in centimeters cubed, but at the same time they've given you the density. If the density is 1, that means that I have 250 grams of water as well. They give you the specific heat capacity and they give you the molecular weight. So there are two calculations. So for the hydrocarbon, we know how much mass we've got, and we know that the MR is 84. So that's going to allow us to work out moles. And then for the water, we know how much water we've got. It's 250 grams. We know that the specific heat capacity, which is C, is 4.18. And we know that the temperature change is 8.2. So that's going to help us to work out Q. So what I'm going to do is I'm just going to change this now so that, because it's not enough space here, so I'm going to just rub it out and scroll down so that I can actually do the working out. So the question is asking me to work out the enthalpy change of combustion in kilojoules per mole. So I have to take all of that information and convert it into kilojoules and then per mole. So as before, we're going to do our 4 steps. So we're going to do step 1. And step 1 is to work out Q. Step 2 is to work out the moles of the hydrocarbon. And step 3 is to divide the answer to step 1 by the answer to step 2. And step 4 is to add a plus or a minus sign depending on whether heat was given out or absorbed, and then round to the appropriate number of significant figures, which is usually 3. So let's get on with doing the working out. Q equals, now I've done all the numbers already. Q equals mass, which are all the numbers in yellow at the side, 250, 4.18, 8.2. So Q equals those 3 numbers multiplied together. And that gives me the answer in joules. So you will see very quickly, once you type those numbers into the calculator, I get 8569 joules, divide it by 1,000, so I get 8.569 joules. Okay, step 2 is to work out the moles. I've just realized that I was a little bit mistake there. I've just fixed it now. Okay, so moles equals mass divided by the relative formula mass or the molecular weight. Now the mass, I've written it at the side already, 0.258, and the MR is 84. So it's going to be those 2 numbers divided by each other, and I get 0.00307 moles. Now step 3 is to divide step 1 by step 2. I've just put an asterisk on the 2 numbers that I need. And I get 2791.2 kilojoules per mole. And then the final step is to add a plus or a minus. Now it's going to be a minus sign because the temperature went up, so it's an exothermic reaction. So I'm changing it to minus. And then to make it to 3 significant figures, I make it 2790 kilojoules per mole to 3 significant figures. Okay, so in just a minute, I'm going to change on to another paper. So this is from an AQA AS paper, June 2016, paper 2. And this one has got all the information there again. So I'm just going to write it at the side so I have it all there. And it avoids me, going through all the paper again, going back to from one page to another. So I've underlined 100 grams of water, the specific heat capacity, and the temperature change. So Q equals MC delta T, M is 100, C is 4.18, and delta T is 38 degrees. There's no need to take away here because they've already given me the temperature change, not the initial temperature. Okay, I'm just going to scroll down and just clear that bit there. Okay, now the other thing I need to know is the hydrocarbon that I'm burning. They give me the before and after weight, so I'm just going to do a takeaway to work out how much hydrocarbon I used in grams. And that comes up to 1.65 grams. So the mass of the actual hydrocarbon is methanol, it's 1.65. Now, I need to know the molecular weight of methanol, so I'm just going to draw it. Okay, so that's CH4O. And if you add that up from the periodic table, it comes up to 32. So I need to know the MR as well. Okay, and they want me to work out the enthalpy of combustion of methanol in kilojoules per mole. And I'm just going to scroll down to the next page and just rub this bit out here. Okay, so we're going to work out the enthalpy change in kilojoules per mole. Step 1 is to work out Q. Step 2 is to work out the moles of methanol. Step 3 is to do step 1 divided by step 2. And step 4 is to change the sign to a plus or a minus and then correct it to the correct number of significant figures, which is usually 3. Okay. So let's start off with working out Q. There's the formula. So I've got the numbers at the side already. 100 times 4.18 times 38. And that comes up to 15884, which is 15.884 kilojoules. Moles equals mass over MR. Did that again because it was a mistake. It's 0.5. That's going to be 1.65 divided by 32. Step 3 is to do step 1 divided by step 2, which equals 30.842, and that's kilojoules per mole. And then delta H equals minus 308.42 kilojoules per mole. Make it a minus and then round it off to 3 significant figures. The answer is minus 308 kilojoules. And that's it. 3 worked examples on Q equals MC delta T.